Welcome. We are part of the NOC AD team, and this is Acoustic Energy Harvesting. Our team consists of NOC AD team member Christina Dronenberg, Rick Tarr, and Bennett Wilson, along with us, three rising MBAs out of the University of Maryland Smith School of Business, Brian Lewis, Akshay Nair, and Jacinta Wadlington. First and foremost, let's talk about the technology. Christina from the NOC AD team has invented a prototype seen here that has 80 plus transducer sensors on it, and that when placed in or around a loud area can take that sound and turn it into energy. Currently, this prototype has been tested within the 30-foot vicinity of FA-18 fighter jets on the carrier runway. The prototype produces 20 watts of energy from the sound produced by these jets. As an iCorps team, our mission is simple: help the NOC AD team find a place for this product in the market. But first, we had a few questions. For this prototype to be viable in the market, we needed to know what places need acoustic energy the most, and with that, we needed to figure out the type of value proposition we could get out of the prototype. As we continued our customer interviews, it became more clear that we should think backwards to find our potential customers. So, what problems are we really trying to solve? One problem is creating energy in places that can't be reached with typical energy solutions. So we want to fill that gap with acoustic energy if possible. Also, the pain of changing batteries and alarms and monitors only hampers production and efficiency. But can acoustic energy serve as backup power to solve this? By seeing potential in these areas, we quickly learned that factories and industrial facilities, along with the military, would be our target markets.
Creating a market for this product through Recertification was a no-go because companies can buy renewable energy credits at a far cheaper price than it would take to buy and install the acoustic harvesting device. Using acoustic harvesting for backup generators didn't pan out either because generators are becoming more quiet and the sound dispersed too quickly to be harnessed by the transducer. And there was just not enough interest in using acoustic harvesting to power runway lights and other things inside the airplane. So we decided to regroup and take a hard look at our value proposition. Relying heavily on interviews that suggested using this as a power source for sensors in the manufacturing sector and the general Internet of Things would be a good market fit, we decided to adapt the technology and strip the 81 transducer model into one miniature power source. We decided to concentrate on using the single transducer model to power an RFID grid for asset tracking on Navy vessels. Asset tracking was a key military pain point that came out of one of our interviews. We recommend that this technology is further developed to lower the minimum amount of noise needed to produce power, ensure that single transducers can function separately in the target market, and generate verifiable metrics and usable test cases to prove the value propositions. Probably the most important is the need to obtain more funding via government or commercial partners.
Thank you for watching, and we're all very excited about where this technology could go if properly funded.